Hey y'all, sorry I can't be there with you today. My daughter has conjunctivitis, also known as pink eye, and it looks like this. Bum bum bum. It's like a eye infection. You get all sort of gross stuff in there. It's pretty awful, and it's highly contagious, so that's great. Um, so you're going to be hanging out with me in digital fashion this morning, and we're going to be looking at 511 expectations. So put that at the top of your notes. All right, we're going to try this warm up together. What I'd like you to do is think about flipping a coin 3 times, or maybe 3 different coins. It doesn't really matter which way you think about it. I want the probability that you'll get at least one head on the flips. So what I'd like you to do is pause me and build me a diagram to do this. Right? Build me a diagram to solve the problem. And I'll show you it in a second. Go. Okay, so here's the diagram that you should have likely drawn. You could probably do this with another diagram, but I think this is the most straightforward. We want at least one head on the flip. So 3 heads is fine, right? And heads, heads, tails, that's 2 heads. That's fine, right? This one has 3 heads. This one has 2 heads. This is also 2 heads. That's good. This is heads and then none after that. That's still 1, right? These are 2 heads, a single one, and a single one, and none of them. So there's 1, 2, 3, 4, 5, 6, 7, 8 things that could happen, right? And 7 out of those 8 give me this, right? Yield at least one head. So that's great. We want to be able to do this without a diagram because I don't know if anybody was super excited to build this. So what I want to do is figure out how to do this same thing without the diagram, and that's called expectation. So expectation looks like this, right? An archer fires at a target. He's got this probability of actually hitting the bullseye. In the competition, he fires 40 arrows. How many times does he hit the bullseye? This is just like a classic expectation problem. And I'm just going to throw you into the deep end. This is what you would do, and then we'll describe why it works this way. So the probability of a bullseye is 2/5. This is just the way you write it, right? The probability of the bullseye is 2/5, so we call P probability 2/5. And N is the number of times the experiment is repeated, right? 40 times he fires the arrow. Yeah, so P and N. So you'd say the number of expected bullseyes is N times P. You'd multiply, here's N, here's P. When you multiply fractions, you multiply everything on top, right? 40 times 2, you think about 40 as a fraction, 40 over 1. And 2/5 is a fraction, 2 over 5. You can either simplify or you can just multiply everything on top. You get 80 over 5, and then you can simplify it down from there, right? Great. So should get 16. We should expect 16. So we want to know what to expect. All right. So this is how it works, right? Let's break it down a little bit. In a game of chance, I love this. The game of chance, right? They're talking about, I don't know, gambling or whatever. You spin a spinner, and it goes around and it lands somewhere 1, 2, 3, or 4, right? They're all the same area, so they should have the same probability, but you win a different amount based on what you spin. So in the 1, you win $1. In the 2, or franc, whatever, in the yen, in the 2 yen, in the 3 you win 5, and the 4 you win 8, right? So it's much better to win a higher number. So in 4 spins, theoretically, how many times should it land on each section? Think about that. So it seems like in 4 spins, theoretically, you should get one of these, one of these, one of these, and one of these, right? So in 4 spins, how much would we expect to win? Well, we'd expect to win $1 because it landed on a 1, and then $2 because it landed on a 2, and then $5 because it landed on a 3, and $8 because it landed on a 4. right? So in 4 spins, you'd expect 1 of each section, and therefore 1 of the winnings that goes along with each section. Cool, so 16, we'd expect 16 bucks. Because this is 8 and that's 8. All right, let's take that and go deeper. Same sort of thing, we win, what was it, 1, 2, 5, and 8. Same spinner. We want to figure out the expected return for 1 spin, right? I know that it's going to land on one, either this or this or this or this. I know in 4 spins, I should make 16, right? So in 4 spins, I could expect 16 of those. Oh, it's hard to write with it. Right? 4 spins give you 16. And so if we have only 1 spin, you should expect maybe a fourth of that, right? So it would look like this. We know that a fourth of the time you'll get $1. A fourth of the time you'll get $2. A fourth of the time you'll get 5, and a fourth of the time you'll get 8. And if you multiply those and add, you should get 16. Sorry, 4. Sorry. Another way to look at it is this. I know in 4 spins I'll get 16. So therefore, in 1 spin, I should get a fourth of that. So in 1 spin, you should get $4. Right? That's another way to look at it. So think about this. You don't just get to gamble for free. They say it costs you this much to play, right? So you have to put your $5 down on the table before you can spin this thing. Hey, you might break out even, and you might win $8, which means you'll have a net of 3, which is really good. But you know, you might get a 1, so you'd lose a little bit, and you might get a 2, so you'd lose a little bit. Do you recommend this person to play this game if it costs you $5? Well, no, right? You should only make $4. Like, you can only expect that you'll make $4 on every 1 spin. So once in a while you'll make more, but it costs you $5. You only expect to make $4 per spin. Costs you $5 per spin. You only expect to make $4 per spin. So you're going to lose 1 every spin, right? So you can assume that you're going to be able to play, and every time you'll lose money on it, right? So you can expect that from this game. All right, let's keep trying. So what I'd like you to try from there is in your packet. This is out of 5-7 expectation. Oh, I guess it says 5-7. We're on 5. Yeah, but find the expectation guy, and we're doing the same thing, right? The football goalkeeper. The solutions are on the back right here, right? So try them out and see where they got these numbers. What I'd also like you to do, if you're having a hard time with this or are done with this, go back in your packet. We didn't get to attack this piece, which was compound probability practice. Right? It was at a 5-9, and it's just a mix of compound probability that'll help you decide, is it independent, is it dependent? Run through those. The answers are on the back as well. Cool. I'll see you guys tomorrow or next round. Bye.